Hello, everyone. Welcome to your Amazon Future Engineer Fulfillment Center tour. My name is Sarah, and I am a tour leader for CMH1, our fulfillment center in Columbus, Ohio, and I'll be your guide on an adventure into the wonderful world of computer science and robotics today. You're going to have a chance to see a few of our robotics fulfillment centers, or as we call them, FCs for short. And this is where people and robots work together to pick, pack, and ship all of our items to our customers. As of today, we currently have roughly 50 robotics fulfillment centers around the globe. And bonus, you'll even get a chance to meet some of our engineers at the very end. I want to send a warm welcome to all of our guests that are joining us here today. I think we're just about ready to get started. So to help us on today's journey of discovery, I have a few friends who have agreed to join me. We're going to take a few moments and head out to the floor to meet them. Pat, can you tell me a little bit about yourself?
Hey, it's actually Trinidad here, Sarah. But thank you so much for the welcoming. We'll see Pat later, maybe. And welcome everyone to Central Texas. Again, my name is Trinidad. You can call me Trin for short. I am broadcasting out of my FC known as SAT2, SAT2. We are in San Marcos, Texas. We're about the halfway point between San Antonio and Austin. We are a robotics site. As you can see behind me, we're going to be talking about our robotic floor, the picking process, and the shipping process. But for now, let me hand you over to my friend Corinne.
Hey y'all, my name is Trent. I am standing here at FTW6 in Coppell, Texas. I'm actually between Fort Worth and Dallas. Fun fact, you're on a Texas tour. Well, I am standing at a 1.1 million square foot fulfillment center. I'm going to be showing y'all the pack and slam process. Not to worry, I'm not going to give anything away too soon, but nothing's actually getting slammed here. Over to you, Sarah.
Thank you, Corinne. All right, before we begin, here are a few things that you probably want to know. Today, your tour will be about 45 minutes long, and then at the end, we'll have a little bit of time to answer any questions that you might have. For now, we're going to go ahead and disable the question box. We're going to open that up right again before we get to that Q&A so that any questions that you have throughout the tour can be submitted through. So make sure that you're writing those questions down as they pop up. Keep in mind that our tours are live and virtual, so if you experience any lag in connection or if we have any technical issues, stick around with us. At each of our tour stops, we're going to kick things off with a trivia question. We want to know how much you might already know. We're going to give you about 30 seconds to answer each question, and then afterwards, we're going to explain the correct answer and talk a little bit about how computer science makes it all possible. If you're at home, you can click on those white radio bubbles to the left of each of the answer choices to submit your vote. If you're in a classroom, hold up a 1, a 2, a 3, or a 4 to signal to your teacher which answer choice you think is correct. You're also going to be introduced to some pretty cool computer science vocabulary along the way. You'll see these vocabulary words pop up on your screen. And teachers, you can access all of our definitions from the teacher toolkit on our website, as well as a recorded version of our tour. Now, do any of you know what the first step in our process is? You're right, it's ordering. Has anyone here ordered from Amazon? I know I do at least 2 to 3 times a week. There are always packages arriving at my front door. So today you're going to learn the entire process from click to ship and all of that super cool computer science behind it. So we're going to start with our first trivia question. Are you ready for some fun? All right. What was the shortest recorded Amazon delivery from our customer clicking buy to the order being in their hand? Is it 3 minutes, 30 minutes, 1 hour, or 3 hours? And a fun fact, Amazon first opened its doors to the World Wide Web back in 1995. At that time, we were just an online bookstore. Over the last 26 years, we've evolved to offer everything our customers could need from A to Z. It looks like we've got about 33% of the vote in, so I'm going to let the poll run for about 5 more seconds. There we go. We're at 67%. Well done, everyone. Let's go ahead and close our poll. And we're going to go ahead and launch our answer for you. It looks like we got 100% of the vote. And let's see. The answer is 30 minutes. So it looks like we had a few of our guests get that answer correct, and 30 minutes is insanely fast. Our average time is around 24 hours. So how do we get those orders to our customers so quickly? The answer? Algorithms. Well, that's it for me. I'll see you at the end of your tour, but for now, enjoy this quick video.
When a customer orders an item on our website, our system uses an algorithm to determine which fulfillment center currently has the desired item in stock. This algorithm then analyzes the customer's address and selects the FC that will provide the fastest delivery time. Computer science allows us to instantly tell customers when they can expect the item to arrive and displays this information on the page. And it's doing this for thousands of items per second. Today, you'll see how computer science is used in each of the following Amazon fulfillment processes. Pick, where we collect customer orders from storage. Pack, where we place orders into boxes for delivery. Slam, where each package is checked and labeled with the customer addresses. Shipping and delivery, the final step where we load trucks with packages and deliver them to your door. Enjoy the tour.
All right, everyone, welcome back to Central Texas. If you're just joining us, my name is Trinidad. We are broadcasting right now from a fulfillment center known as SAT2 in San Marcos, Texas. I mentioned before, we are an AR sortable facility. We are 855,000 square feet, and we're on 4 levels. So we normally reference that we can fit about 14 football fields inside of our building alone. And we are an AR for Amazon Robotic and sortable because we don't carry larger items. We actually carry the smaller items at this particular fulfillment center. So everything that we carry here has to fit into these inventory shelves. So let's start talking about the robotic floor here. At Amazon, humans and robots make an amazing team working together to get products to our customers every day safely and efficiently. And we do that at over 50 robotics fulfillment centers throughout the entire world. We're here at one of them, of course. So the AR floor, you should see 2 things that are mobile behind me. The first thing is the shelving unit, which we refer to them as pods. So those pods are mobile shelving units. It's where we keep most of the inventory that you can order on our website if it's being fulfilled from SAT2. Now, the way that the pod is able to be mobile is by the robotic drive unit on the floor. So the orange unit that's on the floor, we refer to them as drives. We've got 2 sizes of drives here at SAT2, a larger 750-pound one, and then the smaller unit, which is this one right here, and that one weighs about 325 pounds. Now, at any given time, we can have over 20 million items inside of our fulfillment center, and I have a trivia question to start my section off with about those items. So let's go ahead and bring up the trivia question. And that question is, how do you think Amazon arranges our items in our warehouses and in our pods in order to stay organized? Do we do it alphabetically? Do we put things away by their purpose, by their color, or randomly? No organization method at all. We are just randomly putting any item into any shelf that we see is open and available. As we mentioned, you have 30 seconds to submit your votes. That time has already started, so best of luck to you. Again, we can have over 20 million items in just one of these buildings alone. How are we arranging them to keep them organized so we can stay efficient? The answer definitely will surprise you. Alphabetically, by their purpose, by their color, or randomly. All right, so I see we have about 30, 60, up to 60% of the vote now. So I'll give you guys just another 10 seconds. Actually, you know what? We've got 100% of the vote I can see. So let's go ahead and close that poll. Take a look at the results here. I always like to see everybody's guesses. It's my favorite part. Okay, so it looks like 100% chose by their purpose. Well, guys, that is a really logical answer, but it is not the correct answer. So this is going to surprise you. We actually stow things away in our buildings randomly. Yes, we don't put things away by category on the floor. And the reason for that is because we have cloud computing and algorithms that help us out tremendously with finding things. We found that it's more efficient to randomly stow items away in order to make them more available throughout the building. And as I explained, the picking process next should make a lot more sense. But before we get to that, let me finish up on the robotic floor. Now, those drive units, I mentioned they're 325 pounds, but don't let the size fool you in comparison to the pod it's carrying. That pod can weigh up to 1,500 pounds. So yes, that drive unit has a max bench press of 1,500. I won't share mine. It's not as cool. A little embarrassing, honestly. But these drive units are responsible for lifting up the pod. They do that with a hydraulic lift and bringing it up to a working station so that we can then take out an item that's been ordered by a customer. All right. Another thing that you'll notice is the way they're moving around the floor. They move very gracefully. They respect each other. They don't run into each other, and they do it very well. And the reason they're able to do that is because they use wheels and electric motors in order to traverse the floor. And then they also have sensors all around them. So the sensors on the drive unit are what allow the drive to see where it is on the floor, where the other drive units are, and what pod they're picking up. So we've got a quick video to show you about cloud computing and the sensors on those robots so that you can take a deep dive and really understand how that floor functions. I hope you enjoy this video, and I'll see you right after.
After a customer completes their purchase, the order is processed in the Amazon Web Services Cloud Computing Network. Cloud computing allows us to deliver technology resources like computing, data storage, networking, and intelligence through the internet. We simply call it the cloud for short. After assigning a customer order to a fulfillment center, we need to determine where the item is stored. Inside the FC, items are stored in tall, movable shelves called pods. Since items are stored randomly, the item may be stored in more than one pod. A drive unit will eventually deliver one of these pods to a picking station where an associate will pick the item off for packing. An algorithm in the cloud calculates the most efficient combination of picker, pod, and drive unit to process each customer order. But how do we keep track of all the robots? The FC floor is a grid system, and each square has a unique QR code. As the drive unit moves, the robot uses a camera sensor underneath it to constantly scan and update its new location in the cloud. This combination of real-time sensing and cloud processing allows the drive units to work together to clear paths for each other and fulfill orders as efficiently as possible.
All right, so wasn't that awesome? Algorithms and cloud computing help to navigate those drives on the floor so that they know where they are, they know what they're working on, and we keep moving efficiently every day. So we're going to move over to the picking process next. I just need to put up a safety strap before I leave my station. So I'll put up this safety strap, that way nobody walks out onto the robotic floor. Now, speaking of that, that does bring up a couple of questions. Who can go out on the robotic floor? Well, we have a crew of maintenance technicians and engineers that are allowed to enter that robotic floor with the assistance of a piece of equipment. It is a tech vest. It's just what we refer to them as. But this vest has radio modules on it that emit radio signals so that when they're on the floor working, they will, the robotic drives will know that they're out there, and they'll either completely stop or just come to a slowdown to keep that person safe. A few reasons we might go out there is, let's say a robotic drive unit breaks down. It's a piece of hardware. It may malfunction. So if it does, we can have somebody go out there. And us at the stations would be the person to let our Amnesty team know. Amnesty is the team that can enter the floor. Another reason that we might go out there is to pick up an item. Sometimes items do fall out on the floor. And when that happens, that robotic drive unit uses its sensors to navigate around that item. So it creates an alternate path so that it doesn't run over it. So it's pretty neat. All right. Now that we finished up with the robotic floor, it's time for step number 2, which is picking. So step number 1 is you've ordered something. An algorithm has decided that SAT2 is going to fulfill the order. Step 2 will be to pick the item out of inventory. Now, the first thing that's going to happen is that drive unit is going to pick up a pod that's got an item that's been ordered and needs to be fulfilled by SAT2, and it will bring that pod over to this RSOL station. Now, RSOL is an acronym, stands for Amazon Robotic Semi-Automated Workstation, but RSOL is quite a mouthful, so we just refer to them as picking stations a lot. So at the pick station, that pod will park right here, thanks to the robotic unit. A spotlight is going to shine on the bin on where that item's located. Because remember, we randomly stow items, so in each one of those bins, there's probably a lot of different items in there, right? This is where random stow comes into play. On the screen, you'll see there's going to be some extra clues for Linda. Linda is going to be the person, she's picking for us today. So Linda will see on the screen a picture of an item, a description of the item, even a quantity of how many to take out. And with all of those clues, she'll dig into that particular bin, find the item, and then scan it. Now, right above her screen, there is a scanner. All she has to do is have the barcode facing up, wave it in front, and then that computer system will let her know you have the right item for the customer. Now, once she does have the right item, if you want to come in closer here, she'll put it into a corresponding yellow tote. Now, these yellow totes are not customer orders. They've got multiple customer orders, so it's not just one order per tote. The reason we have different totes right here is because they're for different packing processes. And I'll get into that in just a second. But the way that Linda's able to know what tote the item belongs in is because you'll see that above the tote, a sensor lights up to let her know exactly where it belongs. So again, right here, she'll pick the item, put it in the tote, hit the sensor. What we do is we actually have virtually removed the item from inventory. That updates the website. And then we put the item into the tote, and now our computer system knows the item's in the tote. Right? So back to the totes. One of them is for pack singles. So those are customer orders who have only ordered one item, so one item per box. The multi-tote is going to be for our multi-pack process. So this is where random still really starts to make sense. When you order 5 or 6 different things, it could be 5 or 6 different people all picking out one item each from your order. They'll put it into the correct tote. All of those totes will end up at the right multi-pack station, and we will reconstruct your order through a rebinning process, and then get that box out with all the items inside of it. So we let a lot of computers do the work for us. We're just here working next to the robotics. Now, we'll fill up these totes until they're full by either weight or volume. And then if you follow me this way, you'll see that we push the totes through the RSOL station. There's a mechanical lift attached to it. And then that mechanical lift will bring that full tote over to the longer piece of conveyance. Now, if you don't know what conveyance is, that's okay. Conveyors are just large mechanical devices used to get things from point A to point B. And in our case, we use a series of belts and rollers. It's kind of like a roller coaster, to be honest. But one of the things I don't miss about in-person tours is telling the kiddos, no, you can't ride on the roller coaster. Well, since we're doing things virtually, we can do things a little different. So I hope you enjoy this virtual roller coaster ride over to Corinne so that she can tell you step number 3, the packing process. We'll see you there.
What is up, y'all? My name is Corinne back here at FTW6 in Coppell, Texas. How was your ride over? Hopefully y'all didn't lose any items along the way. But welcome to stop number 3, pack. Now that y'all saw that all those items were picked off by our Robot Picker Wonder team and placed into those infamous yellow totes that you see a lot of behind me, it is time to pack some of those items into our famous smile boxes. But before we start, y'all, it is time for another trivia question just to see what you think the pack process works. Alrighty, you have 30 seconds and the timer has started. So how does a packer know the most efficient box for packing? Do they know because of years of training with our experts at our packing dojo stations? Following on-screen commands which are based on item data? Using rulers and tape measures on each item? Or picking the box which simply looks big enough? Because you've received a small item in a big box, right? Maybe that's what happened. So how does a packer choose the most efficient box for packing? Do you think it's choice number 1, 2, 3, or 4? You'll have about 15 more seconds to get your submissions in. Remember, if you're learning remotely at home, just use that white bubble. And if you're in a classroom, hold up that 1, 2, 3, or 4. Alrighty, I will count y'all down from 5, 4, 3, 2, 1. Tony, let's show them. Alright, so the polling results came back with a 50-50%. Okay, half of y'all think we're doing on-screen commands or simply picking the box which looks big enough. Well, those are both really great guesses, but let me tell y'all, It is actually choice number 2, following on-screen commands for the item data. And let me tell you how and why we're doing that. Because Amazon is sending out millions of packages a day. Yes, you heard that right. But how many? Well, at FTW6, we can ship out over 1 million packages a day just from our side alone. So you do the math on that. Alrighty, but we have the responsibility to ensure that we're doing everything in our power to limit our impact on the environment. So we're trying to be as efficient as possible by using little time, electricity, cardboard, gasoline, and still deliver effectively to you, our customer. But what's efficiency?
Efficiency, the ability to reduce or eliminate waste in a process.
Alright, so now that we know what efficiency is and you'll learn what algorithms are in the very beginning with Sarah, Amazon, in order to further our environmental sustainability, we actually founded the Climate Pledge to be carbon neutral by 2040. Pretty cool, right? Well, in order to achieve that goal to be carbon neutral, we have to be efficient. See how it starts to tie in with one another? Well, we need to make sure that we're shipping our customer items in the smallest box possible because we have a lot of cardboard behind me. And how are we going to do that? So, whenever like a game, a book, a garden hose, we have a speaker and a board game that we're going to be packing up today for y'all. But whenever all those items come into the FC, remember that's fulfillment center for short, we're recording mini facts about it, like its height, its width, its weight. Then all of those items are stored into a database. But what's a database?
Database, an organized collection of structured information or data, typically stored electronically in a computer system.
Alrighty, now our wheels are turning, right? Now that we know what a database is. So whenever you click buy on Amazon.com, our system is referencing the item dimensions and the weight from that database. And it's going to automatically calculate using an algorithm. Now that we have all three tied together, we're going to use all those items to figure out which box is going to be best whenever it's combined with other items. But we're at a single pack station, so we're going to do one item and one box. We do have multi-pack items, but we're a single pack station, so let's do that here. So we're actually going to reference the database to use which is going to be the most optimal package size to be efficient while we ship to you. And a special treat for y'all today, I have the world famous packer Azuz here at FTW6. He is the best packer here, so a special treat for y'all. He's going to come on in and he's going to show you how he packs efficiency while using that database. So what's going to happen here at the pack station? And how are we actually going to get the customer orders in that box? Because it all starts with ordering, right? Well, you can see behind me here at our pack station, we have a bunch of items such as boxes. We have tape. We have stickers. We have boxes, more boxes. So many boxes. And we also have the screen and the scanner. Well, everything is going to all start by just pulling that yellow tote from that conveyor belt that y'all had the lucky opportunity to ride on over in. So as that tote gets pulled down, he's actually going to scan the tote into the system, and the system already knows which items are actually inside that yellow tote. Pretty cool, right? Well, then he's going to go ahead and just scan his first item, and as he's doing that, he already performed a quality check just to make sure everything is okay with the package that's going to be boxed up for y'all. And everything's good, so he's going ahead, following those on-screen commands to pick which box is going to be the most optimal to use little cardboard. And then he went ahead and then he got his tape. But let me tell you a little something about this tape because it's pretty cool and it's actually my favorite part about this entire process. So with this tape machine though, it's actually not even sticky. It doesn't even become sticky until it gets pushed with the little button. And as it comes out, it gets activated with a little water. That's a water-based adhesive tape. So that's what's actually making it stick to the box. So it's like an old school stamp, if you know what a stamp is. If not, let your parents know. I'm sure they'll be fascinated that you want to know what a stamp is because it's kind of old school, but it works. So what he did, though, he went ahead and put the package inside, and he grabbed what we call dunnage here in the FC, but it's actually just like air pillows, and that's just supposed to help just keep the box, everything inside of it, safe. After he does that, though, he's going ahead, let me get out of his way. He went ahead and got the last piece of tape, and the tape is going to shoot out right there. And as I said, it's getting activated as it comes out, so it's pretty fun. And he's just going to seal that up. But did you see something that he did that I didn't tell y'all about yet? That's because he got the SPOO label. Let's show them what the SPOO label is. So you can see here on the box that there's no customer information at all. I don't know who this box is going to. Maybe he just bought a game for himself. Nobody knows. Well, actually, our system knows because it's all right here inside the SPOO label. You can look at that. You can see it's just a bunch of letters and numbers, right? That's because it's like a little license plate inside the FC. All the customer information is stored right here. And that's because customer privacy protection is super important. So this item, we don't know who it's going to, but they know, the cloud. There you go. Awesome. After that process, though, he's actually going to place that little box as you just saw. He's actually going to do it onto the conveyor belt. That conveyor belt will take us to our next stop, which is called SLAM. But I'll talk to y'all about that in a little bit. And let me tell you just one more few things here that's going on. Because this is a pretty small site. That was a small little box, right? Well, that's because we're an AR site. So we're an Amazon Robotics site, meaning that we handle items that are 25 pounds or smaller. That's comparable to the size of a microwave if you're wondering for reference, because you can't put a bike in that yellow tote, right? Well, that's because some of our other FCs, they handle the larger items. So we use custom computer vision to scan those items and to build a custom box around it, which is pretty cool, right? Well, we're just trying to minimize the amount of cardboard that we're using. So we're trying to innovate our packaging. So in order to further drive our efficiency, though, as you heard in that video, we're working with manufacturers of many of the items that we sell here to be frustration-free packaging. So whenever they use their packages to ship their products, we're trying to make sure that they're using 100% recyclable and ready-to-ship containers without the need of any additional Amazon boxes. But can you guess how many boxes this has actually allowed us to eliminate? It's time for a trivia question. Alrighty, and remember you have 30 seconds and the timer has started. Alrighty, so since 2015, Amazon's frustration-free packaging has eliminated the need for how many cardboard boxes? Y'all think it's choice number 1, 100,000, choice number 2, 2 million boxes, choice number 3, 100 million, or do you think it's choice number 4, 2 billion? That's crazy, right? Well, how do you think our frustration-free packaging system works? How's that program eliminate all these equivalency of the cardboard boxes? Y'all have about 15 more seconds to get your submissions in. Alrighty, I see a little bit of all the answers being thought about. That's all right. I'll tell y'all about how much we've actually done. Alrighty, I will count y'all down from 5, 4, 3, 2, 1. Let's show them. Okay, so y'all have a 67 and 33% difference. That's all right. Well, I have a little special treat for y'all. It is actually choice number 4, 2 billion boxes. That's because in the last 5 years, Amazon has eliminated more than 1 million tons of packaging materials. So we're trying to recycle whenever possible. Fun, right? Whoa, whoa, whoa. Corinne, where did you go? I'm at our next stop, number 4, SLAM. Sounds like an exciting process because it is. But before I kick y'all off here, let's do a trivia question. Alrighty, and the timer is started as I've told y'all before. So at SLAM, we are checking to make sure that each box is ordered correct. We're trying to just make sure everything is okay here. How are we going to do that? So, do you think we are weighing packages as it goes over the conveyor belt? Using an X-ray to check that the items inside are correct? Are we actually rattling the box and listening with the microphone for any loose items? Or, we're not doing any checks, you're just trying to trick us. Alrighty, y'all have about 10 more seconds. This is going to be a fast trivia question. So go, 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 get your submissions in. Alrighty, 5, 4, 3, 2, and 1. Let's show them. Okay, y'all have it 50-50 again by weighing packages or using the x-ray. Well, let me show you. We're at a weighing station. So the 50% of you who thought it was that we were weighing the packages is actually right. But how are we going to do that? Well, we're carrying out what we call quality control. But Alexa, what's quality control?
Quality control, a process used to ensure that a product or service is free from error.
Alrighty, so here we are showing you the weighing station. So what is happening right here behind me is as the packages are coming down, they're being scanned first. And what's being scanned? The SPOO label. So at the SLAM station, it stands for Scan, Label, Apply, and Manifest. And that's what we're doing here. So carrying out quality control, that SPOO label is being read because it knows what's already inside of that box because of the database. Pretty cool, right? We're referencing the algorithm to make sure that we're carrying out the most effective way with our SLAM station. So what's happening here is this little scanner is actually scanning the SPOO labels as they come down the conveyor belt, just like that. And then they're being weighed. And our system's referencing everything inside of there just to make sure that the weight is supposed to be the correct one. But after that gets weighed, though, let me show you what happens next. Because it needs a label. Where is it going? Right? So this is where the labeling applies. What's happening right here is the little arm will come right down. And with a little poof of air, it's actually applying that customer label. Pretty fun, right? Well, it's actually not slamming it, and that's where the acronym comes from, but no WWE is happening here. No one came down from a corner and smacked that package, which is kind of funny because you would think that, but that's not what's happening here. But let me show you what would happen if there was an error here at our SLAM station. So what I'm going to do is come right on over here. I'm going to grab this package. And let me tell you a little bit about this package real quick, because it doesn't look like any of these other boxes. That's because this is called a SIOC. A SIOC is a ship and own container. So there is nothing wrong with this package. And actually, it's a very beautiful box. But since this is a good package, all it needed was its SPOO label. And this is where that frustration-free packaging comes into play. But what I'm going to show you here is I'm going to turn that SPOO label upside down where there's none on this side. Let's skip the line right here. Whoop! And there, this is what's going to happen. And we're going to follow this package all the way down. So what would happen right here is you would see that package is supposed to get scanned. It does. It gets weighed. But there was actually nothing for it to get scanned. What's going to happen is it's going to get kicked out. And our quality control team members here at the SLAM station will actually dissect the box and figure out what went wrong, or if there was supposed to be something inside of it or too much dunnage. Whatever the issue may be, our quality control team members that you actually see behind me right here, they're actually fixing all the boxes if something were to happen. But we know that everything is okay. The SPOO label was just upside down of this box. So we're going to put it upright, and then we're going to let this box go all the way to where I will also be sending you to our outbound station. So let's see this happen. Ooh, we got a busy line. Skip it. Put our nice fancy box right there. There it goes. Oh, looks like we have a little hiccup, y'all. That's all right. So what would happen, as I've told you, it just gets scanned, it gets weighed, it gets its label, then it goes about its happy way on the conveyor belt to our outbound station. But that's it for me. Oh, there it goes, y'all. I want y'all to see this. Alrighty, it gets its label, and it is off. Well, that box is actually not going to Trent, but I will send you to him. Thank y'all, and I'll see you at the Q&A.
I believe they are, Corinne. I think all these Texas buildings, we're all connected in some way. So thank you so much, Corinne, for explaining the pack and the SLAM process. So we're almost to the entire fulfillment center processes. Let's kind of stop really quickly and recap before we tie things up here at the shipping section. So we've talked about algorithms and how that helps determine what fulfillment center fulfills your order. And then, of course, within robotics fulfillment centers, what pod comes to a certain station and all those details, right? So that's a big help from algorithms and cloud computing. Now that feeds also into the item databases that we talked about at SLAM and at PAC, and how that's used to reference items, weights, and dimensions for efficiency, making sure we're making the best use of our resources and boxes. And then, of course, to do quality control, to make sure that we know what's going out and we know what customer order is being processed through every single package that goes to the SLAM area. Now, after SLAM, this is the next place that these boxes are going to come to, the outbound shipping area, in order to move them out of the building. All right. So we've got a bunch of trucks loaded on the other side of this conveyance right here. So just on the other side on the first floor is where our outbound ship dock is. It's a little bit of a busy area, so we can't go down there live, but we'll show you in a little bit. So now I'm going to have a trivia question for the last section of the tour today about how we load those trailers. So once we bring that up here, I'll read the question aloud to you guys. All right, so how do you think our packages are organized when loading? They aren't. Like stowing, it's just random. Our packages pre-sorted using a high-tech conveyor system. Our robotic arms picking up each item and sorting them into the trucks? Or are we as employees reading each address label and then putting the packages by hand into the corresponding truck? All right, as always, you have 30 seconds. We got this done pretty quickly on my last section with you guys. So we'll see if we have the same results here. Alrighty, so how do you think our packages are organized when loading? You saw a little preview of where I was standing, and that might give you a hint. Yeah, there we go. All right, so we're up to 70% of the vote in. I'll give you an extra 10 seconds here. All right, and we are at 100%. Let's go ahead and close the poll. Take a look at the results. Okay, so we've got our results up here. Looks like we're a little split, 33% for number 2, 67% for number 4. So congratulations to those that chose number 2. We use a high-tech conveyor system. I thought I gave it away. I might have given it away by standing right here next to this awesome high-tech conveyor system. But now that we're here, we know what it is. Let's talk about it. So this is the shipping sorter. This is the machine that's responsible for getting the box onto the correct truck. And we'll start from the beginning. Our boxes come from the SLAM areas. The first place they're going to come on the ship dock is through that tunnel right there. You see that red glowing tunnel. Now, what's happening there is we have a bunch of lasers that are scanning these packages for a lot of critical data points. The most specific and most important ones, of course, is the address of the box. So that way our cloud computing system knows which truck the box belongs on based on its destination, because each of these trucks has its own destination. So as those boxes come through, the first thing that's taken is, of course, what truck it belongs on. And then we're also referencing those item databases again to figure out what is the weight of each package on this conveyor line. Reason being is because we need to know how much effort this shipping sorter needs to put into getting the box off of the shipping sorter, right? So the way we get it off of the shipping sorter is by these shoe pins. Kind of looks like a yellow blur right now, but these are individual shoe pins. That's the piece of hardware that actually shifts to the left once the boxes reach to the correct shipping lane, and it'll push the box off. Now, I mentioned we're over 800,000 square feet, so we have a lot of open bay doors. I'm going to turn you this way really quickly, so we'll take a look at the rest of the sorter. So you can see, now we've got a few things going on right here. First thing you notice, of course, is that box is stuck. We should have an employee any second now. There's a catwalk all along these lanes right here to come retrieve boxes like that. As we're loading boxes in the trailer, we'll see that one's missing. We'll probably find out it's right there, right? Now, the second thing is you're seeing all the different shipping lanes. We have over 30 open bay doors on the side of the building. They're not all in use simultaneously, but we have access to all of them. Our trailers are 53 feet long, and as soon as these boxes get pushed off the shipping sorter, just like you saw right there, they're going to go fall down to the first floor. We have a fun spiral slide. Once those boxes fall down the slide, they're going to fall onto a fluid conveyor line. Now, this fluid conveyor line is telescopic, so it actually extends into the back of that 53-foot trailer. Boxes will roll in there, and that is where our team of ShipDock employees is loading those trailers by hand. So they'll move the box from the end of the sort or the tray, the conveyor to the back of the truck, build a wall, kind of like Tetris, make sure things are nice and compact, nice and tight, so that things don't shift around in transit. And then from here, our trailers will leave to a delivery station. Now, delivery station is that smaller building that has the Amazon Prime vans at. We'll break down our trailer load at the delivery station into those vans, and then those drivers will follow pre-planned routes. Now, in order to have the best routes for our drivers so that we can get things to you efficiently in the time we promised, we have to create the best maps. So we're going to show you a video really quickly about machine learning and how that system is used to create maps for our drivers. I hope you all enjoy this information.
All around the world, humans are constantly constructing new buildings and roads. So how does Amazon keep its maps updated to deliver to even the newest locations? The answer? Machine learning. Machine learning is the science of teaching computers to perform or make predictions based on examples or past experience. To keep our maps up to date, we train computers to use satellite images to detect new roads and buildings on their own. Computers can learn? Yes, but it depends on how well they're trained. To train a computer to detect new roads, we show it thousands of examples of satellite images to compare to existing maps. The computer learns what roads and houses usually look like, and then creates its own road detection algorithm. It uses this algorithm to find and predict roads on new satellite images. Machine learning enables us to process way more data than would ever be possible on our own.
Yes, so because of machine learning, wasn't that fascinating? We can improve all of our processes at a faster pace. So we don't just use that for creating maps for our drivers. Machine learning is active in every part of the fulfillment process to process a lot more data than we can as humans. A good example of machine learning's results here at the shipping sorter is this ship sorter will speed up and slow down. It'll adjust the speed based on the capacity that is on it. Right now, it's a very light load, so it's going at its top speed, which is about 25 miles an hour. But on busy days like Prime days and peak time before Christmas, this will be completely full from end to end with boxes. And in that case, it'll slow down so that it can accomplish better kickouts whenever it's pushing boxes off of the sorter. Well, I want to thank you guys so much for visiting SAT2 and FTW6, your Texas store, to talk about machine learning, algorithms, all these different pieces of data that we use to ship to our customers every day. Without further ado, I'm going to hand you back to our awesome host, Sarah, so that she can let you know what we're going to do next before we take your questions.
Wonderful. Thank you, Trin, and welcome back, friends. How was your tour? Did you learn something new today? Now, when you see those Amazon packages on your doorstep, you can share with everyone exactly how it got there. So now we're going to open up that question box as promised and give you an opportunity to submit all of the questions that you've had through the tour. But first, while you're typing in those questions, it's time to meet some of those engineers who made the technology you saw today possible. Who knows, if you keep studying computer science and engineering, you might be our coworkers someday.
My name is Erica, and I'm a research scientist at Amazon Robotics focused on hardware.
My name is Rohit Raman, and I am a software development manager here at Amazon Robotics.
My name is Julie Mitchell, and I manage the Solutions Design team at Amazon Robotics. In Solutions, we take different building blocks made up of hardware and software that come together to form a system. That system does complex tasks like picking, packaging, and shipping Amazon's orders to our customers. I'm from just outside of Boston, Massachusetts.
I am from Mumbai, India.
I'm from Nigeria and Dubai, UAE.
Introverted, sporty, musician, gamer, and used to love to read a lot.
A little awkward, athletic, fun-loving, and a good friend.
Shy, 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 shy.
More recently, the team I'm leading, we work with a lot of robotic sensors. Sometimes these sensors don't work, or the robotic equipment doesn't work as expected, and my team helps us understand what went wrong with those sensors and how can we ensure that they never have those same problems again.
As a research scientist, I develop innovative physical items and physics simulations, kind of like video games, to be able to solve robotics problems in our fulfillment centers. What that looks like is getting robot arms to reach into shelves, pick up items, and then those get routed around a fulfillment center to get to the package that arrives at your doorstep.
As the head of the solutions design team, I get to innovate with my team on next generation solutions technology that will help Amazon ship globally in our one-day delivery windows.
I really love the way in which robotics is a fusion of a number of different principles and disciplines. So there's mechanical engineering, electrical engineering, software engineering, all coming together to just kind of create this super cool device.
Most people who work in software, they see something on a screen or a computer, but when we write some code, we actually see the physical robot do something, which is very cool to watch.
I would encourage students to get into careers in tech if they want to make a difference in society and get to work on technology that society uses every day to help advance our lives.
Tech is a field that is constantly changing and constantly evolving. And so if you work in tech, you're going to be working on problems that just evolve and change, and you'll likely never get bored. My friends and my family all get Amazon packages, and I get to see how the work that I do impacts a lot of different people, and I think that can just be really rewarding and fun.
All right. Well, hello, everybody. My name is Tony. I am your tour leader here in Minnesota, and I've been running this tour behind the scenes. Since these tours are live Monday morning, I have to control all the polls and all that stuff so that we can have a live tour for you. But it's now time for that question and answer. So what I would like everybody to do is to type us some questions. So on your screen on the right-hand side is going to be your control center. It's either going to be popped out or you might have to pop it out. So and type us some questions. So the first one we have, now we don't have too much insight on the first question because we don't know too much about delivery after our buildings. We're not experts. We're more experts inside of how we make the packages get delivered, but we're going to attempt it a little bit and we'll see what we can come up with. Trin, I'm going to send this first question to you. The question is, I've had a lot of packages go missing, and after Amazon suggests I request a refund, the packages show up. What happens there?
Yeah, excellent question. So I have been inside of sortation centers and delivery stations after the fulfillment center. So like I mentioned, after things leave the FC, they go to a delivery station. So at that building is where they do a lot of sorting onto different trucks that go to different areas. So you can kind of think as a delivery station of sort of a middleman, and in the delivery process, and things can get mixed up there. We're all human, we have human error sometimes. So in the case that they do eventually find the right track, if that one ended up on an incorrect truck, we do want to get the package to you. I have myself experienced where I've got my money back or even got the item replaced and then got that original item eventually afterwards because it's already in transit, already on its way to you. So we want to make sure that we get you things as quickly as possible. But in the case where we resolve the issue, everything is about the customer. We always stay customer focused, customer obsessed. So we'll still send that package out to you even after it was found, sometime afterwards. I couldn't explain it in detail. I apologize. But, again, hope you don't experience that too much. Thanks, Tony.
Yeah, no, thank you for highlighting a little bit. Like before, I said we're more experts on how the packages are in these fulfillment centers. And once it leaves the building, Trin's a better expert than I. I'll say that. How about that? There we go. Miss Corinne, we're going to go to you. How many boxes do you have inside of your building that you can produce a package for all of us?
We have up to 20 boxes that we can use to pick which one that we're going to use to be the most efficient while we pack. It does depend on also the site. Some places have smaller amounts of boxes. They can have up to 15, but it all just depends on the site.
Coolio. Thank you. Mr. Tran, a famous question for
Sure.
you. How many robots do you have inside your building?
Oh, excellent question. So I wouldn't be able to pinpoint exactly how many down to the number here. There are several hundred of them. We have over 200,000 robotic units across the 50 robotic sites that are out in the world. But we expand and condense AR floor sometimes because we're always experimenting with different processes and trying to improve things with the ideas of the employees here. So in the last 2 years, we've actually expanded our AR floor here at SAT2, and we've added several dozen more robotic units. There are a few hundred in each building, but I couldn't narrow it down to an exact number. Over 200,000 across all of the robotic sites, though, so quite impressive. Thanks, Tony.
Great, thanks. Sarah, I won't leave you out since you're not typing to anybody. Sarah, do people need a certain degree to work at Amazon? Can you talk about that?
That's a wonderful question, and absolutely not. We have individuals throughout Amazon, even through corporate positions, that do not have a degree and have been successful just taking learning and being curious. First and foremost. So we have a lot of courses that are available. If you've looked online, there have been articles recently where you can take computer science classes as an Amazon employee who's in a non-tech role and transition over to AWS into computer science engineers. So there's a lot of opportunity, doesn't necessarily require a degree. It's all about your experience and just applying for new roles and taking advantage of those opportunities.
Great, thank you, Sarah. Miss Corinne, how many people work inside of your facility?
Like my first answer, it all depends on the site type, but we have up to 1,500 employees here. During our peak season, we can go up to about 3,000. We do double in size, but for most of the year, we are at 1,500.
Great, thank you, Corinne. Trin, we'll go to you. How often are the robots serviced to keep them working, and what type of maintenance is required?
Yeah, excellent question. So fun topic to talk about. The robotic drive units are tended to by our reliability, maintenance, and engineering staff, and also the Amnesty team. Amnesty I referenced when we were on the AR floor and talked about who gets to go out there and interact with them. They're serviced on a daily basis. They charge on a daily basis as well too. So just a couple of key points to talk about. When it comes to charging, they undock once a day from their queue, go dock to a charging station in the middle of the floor, and they'll dock one time a day for about 5 minutes, get a nice good charge to last them throughout the shift. And then once a week, they each have a lengthier charge for several hours to kind of boost them to begin the week. Now, when it comes to maintenance, it happens as needed. So when things break down, if I were at a picking station, I would flag on my computer screen that I see a drive unit that's kind of just maybe spinning or it's stuck or, it stopped functioning. At that point, Amnesty would respond to that to my station and then go retrieve that bot. On every single AR floor, though, at the corner, there's a large caged maintenance area. So directly adjacent to the robotic floor is where maintenance works on those drive units to get them back on the floor as soon as they're good to go. Hope that sheds some light on a few different points. Thanks, Tony.
Thank you. I want you to shed some light on that conveyor behind you. What's going on, man? It's not working.
Yeah. There's actually a jam right there. So you'll see my buddy John Ogburn. He's down there with the ponytail. He is clearing that jam. So, like I said, these are, people think Amazon is no one touches us, but stuff like this happens, on a daily basis, and we have our, maintenance and engineering here to help out. So it's just a jam. They'll get it fixed.
And thank you for your camera person helping us see, because it took me a second. Whoever you have today. Yeah, there we go.
Sweet Amanda.
Nice. Thank you.
My friend Amanda is with me today.
Thanks, Amanda. You're helping all of us see that person. It took me a second. I do have to wear my glasses. But all right, here's one coming in the question box, and we'll give it to Corinne. Corinne, do you get stuff for free?
Do I get stuff for free?
Yeah.
No. I mean, we have swag that comes in for our team, our tour team that will come in, but like these shirts, I got this shirt for free, but
your shirt, not mine. Yeah.
I mean, no, I don't get goods or anything like that for free. We do get a discount, but nothing for free.
We do get a discount, and the nice thing about our discount, it also works on top of sales. So if you use your discount correctly, when Prime Day is happening and maybe an Apple Watch that I'm not wearing today is heavily discounted, I get another discount on top of it. So, use your discount correctly. Optimal usage. Awesome. Let me see what we're doing with time. Okay, we have about 1 more minute for questions, and then I got to start talking about some other stuff. Let me see what other questions I got here. Trin, are you worried about automation taking over jobs?
Ooh, I love that question. So no, I'm not worried at all. We've got a few different initiatives that we're taking on in that respect. But let me start by saying every time a new piece of automation gets introduced in my building, there's always somebody assigned to monitor it or, some problem solve with it or tend to it. So the robotic arm got put in my warehouse downstairs. Somebody had to man that robotic arm to make sure that there was a man or a woman there to tend to it. So every time we introduce something new, there's always barriers and problems that could arise with it. So that always requires somebody to monitor it. Now, for that, something very specific that we're doing is Amazon Technical Academy that we just initiated this year, where we're training current FC employees who may not have a background in robotics or engineering in order to take on those higher level jobs that will eventually come with more automation. So, not only are we investing in the automation of warehouses to make things safer and more efficient, but we're also investing in the people to work with those new pieces of tech. So thanks for letting me shed some light on that, Tony.
Like your tech conveyor that's not working? See, we need people.
Yeah, no. You see, we need engineers to help make this a little bit better. Like there are really cool things to help it kind of go smoothly, but stuff still happens.
Yes. All right. Last question I got in the question box, and then we'll move on to the last things I need to talk about before the end of the tour, and that is for you, Corinne. How are the floors cleaned with the bots moving all the time?
I'm sorry, what did you say, Tony?
How is the robotic floor cleaned with the robots moving all the time?
Well, we have an amnesty team, so if anything were to ever happen on the AR floor, I thought you were talking about my clean floors that you see behind me.
Yeah, they're looking very clean. Yes, they are. Yes.
On
in
the
the
AR
robotic
floor,
cage
though.
area. Yeah.
Down
Yeah.
in our AR floor sites that we do have, we have an amnesty team. So I don't know if Trent showed y'all, but there is a battery pack vest that will actually illuminate. So if there was an item that were to fall off a pod, maybe it stuck out. I know Emily said, she's another core leader here with us, sorry. That one time there was a big dog bone that got placed inside one of the pods and it randomly fell off because it went in passing. So things like that do happen, but our amnesty will actually go out on the floor, they'll pick up that item, and then all the robots, they're super courteous, unlike the drivers here in Texas, and they'll actually slow down around her or him whenever they're out on the amnesty floor.
Yes, and
amnesty team.
yes,
it's a Monday.
Sorry, and I'm cutting you off. I'm getting eager to put up my slides. I'm sorry I cut you off. We're not production is not running 24/7 as well. So we do have some time in the building where it is shut down, where the whole building can be cleaned and maintenance can happen. So the robots are not moving 24/7. But let me make sure I'm showing the right thing. Whoops, right. That screen. All right, everybody. So I have 30 seconds left with everybody, and this is what I'm going to share for you. Let me make sure you can see it. Waiting for next screen. There we go. Now you can see it. All right, everybody. So AmazonFutureEngineers.com, the website. So this tour is a part of that department, which is called Amazon Future Engineers. And there we offer many more things in this tour, like class chats, where you can have an Amazon employee talk to your classroom. Now, it does take 30 days to set up, and that Amazon employee will talk to your class for 30 minutes. Pretty cool. Amazon Cyber Robotic Challenge, where students can build their own robots. And last but not least, scholarships and internships. We just gave away $140,000 scholarships, and that will reopen for new applications in November. Now let's go to the next screen because it's very important. Slide move. Thank you. And thank you for touring with us. We really do appreciate it. Teachers and staff, please help us by filling out a survey. You are going to get a link to a survey in your email. If you fill it out, you could be a winner on this Monday morning. Well, next Monday morning. If you fill out the survey, you're going to have a chance to win a $50 gift card. Now, we do give away 3 each week, so please fill it out. Don't forget, do it today so you don't forget on Friday because we give them out on Mondays. So please fill that out and help us grow this program. Well, that's it for this Monday morning. Thank you for attending your Amazon Future Engineer Fulfillment Center tour. From all of us, have a great rest of your day.
We're
Bye, y'all.
running again. See you later.
Bye. That's good. I'm glad you're running
Bye.
again. Bye, everybody.